Hello friends, in this video I am going to describe another sorting technique. That is the insertion sort technique which we find in the data structure, study of the data structure. There are numerous sorting techniques, as you know. There are bubble sort, insertion sort, selection sort, heap sort, quick sort, merge sort. There are so many sorting techniques, out of which in this video I am going to describe this insertion sort technique, in which by this technique we can just sort an array in an ascending order or a descending order maybe. So I will just take a schematic representation. I will show you a schematic representation in terms of a small array and show you the technique before I go into writing the code and explaining it to you. And then just let me write the a small array named as A. I will take 3 to 4 elements in that array and I will show you what is the underlying logic in this insertion sort technique. So I will take this array. Suppose I am taking this array. I am taking 4 elements. Suppose 0, 1, 2, 3. So the first element let it be 44, then it be 33, there is 66, and this is 11. So suppose these are the 4 elements in this array, which is called A. And what is the insertion sort technique? I will just show you in a tabular representation. Let me see. First, we will write like this. A is A0, A1, A2, A3, and write the respective elements underneath these index positions: 44, 33, 66, 11. Now, what I will do, this is the first step, that is the k is equal to 0 step. In this step, in this entire sorting technique, I will take a logical -1 position, a -1 position, and keep the smallest element which is possible, the smallest value which is possible, that is -infinity. This is for the understanding of the entire logic of the insertion sort. We will keep this -infinity in this position, which is the smallest element which can be thought of. So all the other elements in this array will be definitely greater than this element. So we will just follow a technique of shifting the smaller elements to the left hand side, the smallest element to the leftmost side, and so on and so forth. But for this case, we will definitely see that the smallest element, whatever may be the smallest element in this array, it will be always greater than the -infinity value, because this is the smallest element which is possible. So definitely no element will cross over this -infinity to come and take the place of -infinity. So we have taken this -infinity as a delimiter, or it can be taken as a sentinel or something which limits the transfer of elements or the repositioning of the elements on the left hand side, so that there is no crossover after this -infinity is encountered with. So I have taken this -infinity over here. So in this case, we will just encircle this 44 and see whether this 44 is to be compared with the leftmost neighbor. So this leftmost neighbor is just -infinity, and which is definitely less than 44, and this 44 is greater than -infinity. So 44 is never less than -infinity. It cannot be less than -infinity, as we were discussing just a bit ago. So that therefore this 44 will be taken to be trivially sorted, and after this there will be in this step there will be no repositioning of this 44 to be taken to the left hand side. So this -infinity will block this 44 and prevent this 44 to go on to the left hand side, because -infinity is less than 44. So in this k is equal to 1 pass, we see that this -infinity will remain over here, 44 will also remain over here, 33, 66 and 11. So these two steps seem to be the same. There is no change in these two steps. Now what we will do, we will just come in a diagonal fashion and encircle this 33 in this number 1 step, that is a k is equal to 1 step, and again see and compare this 33 with the left neighbor, that is 44. see this 33 is less than 44. So, if it is less than this left neighbor, then this 33 will go on to the left side and 44 will take its position. So, this is not a swapping, it looks like a swapping in this case, but it is not a swapping, it is just a repositioning as we are doing in doing over here. So, this this 33, since it is less than 44, will go on to take this position, 44 will come to this position, and then 33, just imagine 33 in this position, and see, then 33 will be again compared to the left neighbor, that is minus infinity, and minus infinity is less than 33. So, 33 will be staying in that position, that is the position where the 44 is now placed. So, in k is equal to 2, minus infinity will remain over here, 33 will come over here, 44 will go over here in this fashion, 66 will be here, 11 will be here. So, this is the position in the k is equal to 2 step. Now, we will again go in a diagonal fashion and encircle this 66, and see this 66 not less than 44, it will not go to this side because this side is sorted. See, this 33 is less than 44, it is sorted in ascending order, 33 is less than 44, so 44 is greater than 33, and this 66 is greater than 44 in turn, then this 66 is in turn greater than 44. So, there is no question of this 66 going to this left side, and there is no question, however, to just compare this 66 with this 33, there is no question arising for this case. That is, 66 is not going to be compared with 33 as it is well greater than 44. So, it will be just compared with 44. See that this 66 is greater, it will not be taking the position of 44. So, there is no question of comparing the 66 with 33, and 66 will remain in this position. So, in the next step, that is k is equal to 3 step, minus infinity, 33, 44, 66, 11. So, these k is equal to 2 and k is equal to 3 snapshots seem to be the same, because there is no displacement or there is no repositioning of 66 done. So, these two step arrays, in these two steps the arrays remain the same. So, there is no change in the position of the elements in the array. So, after this we will again go in a diagonal fashion and encircle this 11. See, this 11 is now being encircled, and see, this 11 will be now compared with 66, it is less than 66, it will go in this position. Again it will be compared with 44, it is less than 44, it will occupy this position. Again, if this 11 will be occupied or compared with 33, and again 11 will be shifted to this position, and see this, then 11 will be compared to minus infinity, and is minus infinity is less than 11. So, 11 will be stuck in this position, and the repositioning of 11 takes in a chain system, and it will just stop over here, and 11 will be positioned in this, in number 0 position, and see this 66 will be taking the place of 11, 44 will be taking the place of, 44 will be taking the place of 66, 33 will be taking the place of 44, 33 will be taking the place of 44, 11 will be shifted over here, minus infinity will be here, k is equal to 4. After this we see that this last element of the array, that is 11, has been encircled, and there will be no elements left over after 11. So, in this position we should get the array in a sorted order. So, let me see whether the array is in a sorted order. 11, 33, 44, 66, the array is sorted in an ascending order. So, this is the entire logic, underlying logic of the insertion sort algorithm, and we will discuss the code. After writing the code, I will get back to you with the explanation of the code section along with the dry run. So, as I have written the code of the insertion sort algorithm, so I am just going to describe this algorithm or explain this algorithm in the form of an example. So, suppose we will take a small array containing 3 elements. Suppose these contain 3 elements, 44, 33, 11. So, this is the array which is under consideration now. Suppose this is A. So, base address of this array will be supplied over here, and number of elements n is equal to 3 in our case is going to be supplied as the second argument. Name of the function is insert sort, nothing to return, that is why return type is taken to be void. So in this position 0, 1, 2. So what we have taken? We have taken three variables I, j and t. I and j are loop variables, t is a temporary variable. So for I is equal to 1, I less than n, I plus plus, we will enter a nested loop construct in this insertion sort algorithm. There are two for constructs, and in the first outer for we see that for I is equal to 1, I less than n, I plus plus. So I is equal to 1, first the I will be initialized to 1 and it will be compared against the value of n, that is n is, in our case it is 3, it is I is well less than 3, so we enter the for loop, outer for loop. We assign this ai to the temporary variable t. So temporary variable t will now contain ai, means a1, that is a1 is, what is a1? 33. So a1 is 33, it is going to be assigned to t. Now we will enter a second loop. This is a decrementing for loop, this inner loop. J is equal to I minus 1, I minus 1, I is 1, j is equal to 0. So j greater than or equal to 0, it is greater than or equal to 0 because it is equal to 0. So we enter this inner loop. Now there is a checking, if t is greater than aj, if t is greater than aj, let me see, 33 is greater than a0, a0 is what? 44. 33 is not greater than 44. So this expression, this if will be skipped. So we will not encounter this break statement and go to the next line of this for loop, that is aj plus 1 is equal to aj. What is aj plus 1? J plus 1 is 1 is equal to aj, aj means a0, a0 means 44. So now a1 is equal to 44. So after this, see this, we again go to this second inner for loop after decrementing this j value by 1. So j will become, now it was 0 previously, it will become minus 1 now. So minus 1 is not greater than or equal to 0, the condition does not hold, we will go out of this for loop, we will go out of this inner for loop. And after inner for loop, we encounter a statement, that is aj plus 1 is equal to t. So aj plus 1 is equal to t means now j is minus 1. So minus 1 plus 1 means 0. A0 is equal to t means, what is the value of t? We have taken the, we have kept the value of t as 33. So A0 will be now 33. Now see, A1 is now 44, A0 will be now 33. So the array will be now changed in this way. See, A0 is now 33, A1 will become what? A1 will become 44 and this 11 will remain over here. So this is now the updated array looks like this. So this is the updated array A. Now we go to this outer for loop once again, try to enter the outer for loop after incrementing the I value to what I value was 1 previously, now the I value will become 2 and 2 is definitely less than 3. So we will enter the outer for loop once again for the second time. Again we will assign ai to t. So t will be now ai. What is I value? A2. What is A2? 11. T will contain 11. Now we again try to enter this inner loop. J is equal to I minus 1. What is the value of I? 2. 2 minus 1 means 1. 1 greater than equal to 0. Yes, it is greater than equal to 0. Then we enter over here. If t greater than aj, what is t? 11. 11 greater than aj. What is aj? aj is 1. A1. A1 is now 44, 11 is not greater than 44. So this if will be again skipped, we will come to this line, aj plus 1 is equal to aj. What is aj plus 1? A2. And what is aj? A1. So A2 will now contain what was in the A1 position, that is A1 is 44, A1 is 44. So A2 will contain 44. Now after this we try to enter the inner for loop the second time after decrementing the j value by unity, that is j value will now become 0. This is greater than equal to 0. We again enter the inner for loop for the second time. Now again we compare this, we see this, check this condition if t greater than aj. What is t? T is 11 and aj means a0. A0 is what? 33. 11 is not greater than 33. Again we will skip this if block, we will not encounter this break statement, we will go to this expression statement, aj plus 1 is equal to aj. Now aj plus 1 means a1 means aj, aj means a0, a0 is 33. So a1 is now 33. After this, again we decrement j by unity. So j becomes what? J becomes now minus 1. So minus 1 is definitely not greater than or equal to 0. So we come out of this inner j loop, inner for loop, and come to this expression statement, write aj plus 1 is equal to t. So what is aj plus 1? Aj plus 1 means a0. So what is a0? a0, j plus 1 means minus 1 plus 1 means a0. What is a0? a0 will now become t. So t is now what? 11. So now see, a0 has become 11 and a1 has become 33 and a2 has become what? 44. So now see, if we write the array now, updated array will look like this. A0, that is the 0 position, will contain the value 11. The 1 position and the 2 position. 1 position will contain what? 33. And A2 position will contain what? 44. So now the array looks like this. Now we'll come to the outer for loop once again after incrementing the I by unity. I will become now, it was first 1, then I has become 2, then I will become 3, which is not less than 3. So we will not enter this outer for loop and come to the closing brace of the function body. So in this case, so since we are done with the function, let me check whether this array is now in a sorted manner. So the array is now definitely in a sorted manner. This is 11 followed by 33 followed by 44, the expected sorted manner which we have got now. And our purpose was just ascendingly, we need to ascend, we sort in the ascending way, and we have sorted the array in an ascending order, and we have got the desired result, and this is the entire logic of this insertion sort algorithm. If you have any doubts and queries regarding this entire explanation, you can well post your doubts and queries in the comment section below so that I can address them. Thanks for watching this video.